Okay, so carrying on from where we left off really on the periodic table, I wanted to cover with you what isotopes are. And the way you describe these, I think you have to be careful with your wording, because what you're talking about are two atoms of the same element that have the same number of protons but a different number of neutrons in the nucleus. Now, you might say, well, of course they're in the nucleus, they couldn't be anywhere else. But the reason I'm including the words in the nucleus is so that I show my examiner I know that the protons and neutrons are in the nucleus. And the point about isotopes is that they have the same chemical properties. Because they have the same number of protons, they have the same electronic structure, and so they have the same chemical properties. But they're not the same relative atomic mass because they have a different number of neutrons in the nucleus. Okay? So my first point for this video is what isotopes are. You need to be able to say that. Now, elements template form of a substance. They are the building blocks of material. Mixtures. Well, here you have two or more substances together, but not chemically combined. They can be separated by physical means, like filtering or evaporating. Those are physical means of separating, whereas a compound is two or more elements combined chemically, bonded together. So, elements like the whole periodic table here, these are the elements. Mixtures, two or more substances, might be elements, might be compounds, but they're mixed. For example, sand and polystyrene. A mixture of sand and polystyrene, you could separate those by physical means. If you dump the whole thing in water, the polystyrene will float, the sand will sink, and then you can evaporate the water off the sand to get you back the sand. So filter out the polystyrene, evaporate the water off the sand, and you have your two substances physically separated. A compound, like carbon dioxide, magnesium oxide, sodium carbonate, these are chemically combined together. You can't filter them or evaporate them to separate the sodium and the carbon and the oxygen from sodium carbonate. So there you have elements, mixtures, compounds. Now, I have a question or two on the periodic table for you, and I'll do a little bit of this for you and leave you to do the rest on your own. So here it is. So let's scroll up to the top here. So first question, what is the atomic number? It is the number of what? Well, it is the number of protons, and again, I would say in the nucleus, just to show that I know. The mass number, well, hopefully you'll remember that that is the number of protons and neutrons. Again, in the nucleus. Explain why an atom has no overall charge. Well, notice there are 2 marks here. So you're going to say an atom has the same number of protons and electrons the charge on each proton is +1, the charge on each electron is -1, so the charges cancel or balance. Now, you say there's 3 points. I'm not going to argue with you with that, but I don't feel that I can answer that question any less than those 3 statements. Because if I didn't say this, then the fact that I have +1 here and -1 here wouldn't mean that I have no overall charge. So, because they have the same number of protons and electrons, and the charge on the proton is +1, the charge on the electron is -1, that's why they balance. Now you might say that that bit isn't actually necessary, but I wouldn't feel comfortable not saying it, so that's why I've done that. So explain why fluorine and chlorine are in the same group. Again, 2 marks. Well, from a first mark, and we happen to know that's 7, because we know they're in group 7, right? So it says, why are they in the same group, and give the structures? Well, now we have to look at a periodic table, which I have down here somewhere. There we go. So fluorine, if I look down here, I see it has 9 protons, therefore it has 9 electrons. 2 of those will be in the first shell, so there'll be 7 in the outer shell. Fluorine then is 2, 7. Okay, and chlorine, that's 1 further down, so there's going to be another shell in there, but let's just check that. So we have 17, the first 2 will be in the first shell, that leaves us 15, 8 will be in the next shell, so that leaves us 7. So it's 2, 8, 7. Back up to where I'm putting my answers. Chlorine, 2, 8, 7. And that makes sense from what we know about the periodic table, because we know as you go down a period, fluorine is 1 period above chlorine, you can see in the table. If we go back down here. There's fluorine, there's chlorine. So going down 1 period, we have 1 more shell of electrons. When we went from here to here, and then from here to here, each time we go down one and start a new period, we have filled one shell of electrons. So we're going to go 27, 287, 2887 will be our electronic structure. Every time we go down one, we have another full shell. So 287 for chlorine. In D then, the diagram shows the electronic structure of an atom of a non-metal. What is the chemical symbol of this? Well, we're going to say we've got 2, 8, 2, 4, 5, 6. 286. So we know we have 6 electrons in the outer shell, and it's 286. So let's go. 6. Well, there's 26. There's 286, right? So it's sulfur. Gotta be. So, I will leave you to do questions 2 and 3 for yourself. So stop the video and then come back to me having done those. So, the periodic table is now the arrangement of the elements in order of increasing atomic number. Let's take a few of those out. The rows are called periods. Columns are called groups. And hopefully you remember that from the earlier video on the periodic table. Why do you leave gaps? Well, because his pattern showed that there should be an element in those places. And he was right. Later on, those elements were found. So he was right. So this section of the periodic table shows the positions of some elements. Give the chemical symbol for one of the noble gases. Well, you've got helium, neon, argon over here, so any one of those will do. Draw the arrangement of electrons around the nucleus for the noble gas that you chose. Well, if you look at helium, for example, you would have 2 electrons. Neon would be, if we go down to neon, would be 2, 8. Because, sorry, I should have paused a little longer there, you have 10 protons, therefore 10 electrons, so there will be 2 in the first shell, 8 in the second. Was it argon was the next one? Argon, yes. So argon would be 2, 8, 8. So whichever one you chose, it's either 2, 2, 8, or 2, 8, 8. Why do the electron arrangements of lithium, sodium, and potassium make them react in a similar way? They all have 1 electron in the outer shell. Small pieces of lithium, potassium, and sodium are added to water. Remember which way the reactivity goes. If we look at the table, lithium, sodium, potassium, reactivity is increasing as you go from lithium to potassium. So lithium, sodium, potassium would be the order of reactivity. Most reactive first, potassium, then sodium, then lithium, because they want the most reactive first, don't they? Okay, I'm going to do more of this a little later on. So I'll use this as a good example for that. You have over here 2 sodiums Note the state symbols, solid and liquid. 2 waters. Over here I've got 1 sodium, 1 oxygen, 1 hydrogen. So I would put a 2 in there. So that gets rid of, or accounts for those 2, and 2 of the oxygens and 2 of the hydrogens. And here then I'd have H2. So the point being that I have to have the same number of everything over here. So I've got 2 sodiums here, and I've got 2 sodiums here. I've got 4 hydrogens. There's 2 of them, 2 times H, and 2 of them there makes 4. I've got 2 oxygens, and there they are. So I have to account over here for everything I've got over here. Question 3, which element, W, X, Y, or Z, is a group 0 gas? That would be a noble gas. Well, it has to have either 2 or 8 electrons in the outer shell. And the only one that has that is Y. Nitrogen. Well, if we go back to our periodic table and look at nitrogen, nitrogen's got 7 protons. That's going to be 2, 5, right? And there it is. Group 7 gas. That's a halogen, right? That's going to have 1 electron in the outer shell. Well, that's going to be Z. Oops. React violently with water. Well, we'd expect 1 electron. My apologies, is X. 7 electrons in the outer shell. And Z then would be the one that reacts violently with water because it is group 1. So, which 2 groups of the periodic table do not contain any non-metals? Well, let's have a look. They're all metals. And they're all metals. So we have the groups 1 and 2. And there it is. I will come back to balancing equations.